So, as we begin lesson E1, we're looking at slope and proportional relationships. Please don't visit right now. Thank you. So, one of the things that we are going to be working with this is modeling different linear and nonlinear relationships, and we're mostly going to be looking at linear. We're going to be using graphs, tables, equations. We're going to be talking about the unit rate, our rate of change, slope, and proportion. So, proportional relationships, we're going to be looking at all those. So it says, is there a relationship between your age since birth and your height? Do you think there's been a relationship that as you've aged, what's happened to your height?
Gotten taller.
You've grown, right? So as your age increases, right? As your age increases, our height has increased, right? And if we're thinking about it increasing, and for a lot of you starting now, or maybe recently, some of you are probably have hit your height, and some of you will probably continue to grow taller. Okay? It says, how could we display this relationship? So if we are looking at, you need new notes?
Yeah.
Got it. Put your name on the front. Okay? So if we are looking at a graph, and you had age down here, and you might have, right, from 0 to 1, we could have 2, we could have 3, we could have your age, and we could say in years, or we could say in months, right, depending. And then we might have our height. Now, most babies are born maybe between 20 to maybe 30 inches, 33, some of you maybe. So if we were thinking in terms of feet, we might say maybe we want to put a broken graph and we want to go 2 feet and then 3 feet, right? And we'd want to maybe show something like this. Because when we start off at age 0, we're saying, oh, they do have a height at that point. It's just pretty short, right? So as age increases, we think it kind of goes like this for a while, right? But then what happens? Like, is there a time when you're about the same height for a while, right? And then all of a sudden you hit a growth spurt and you do something like this, right? So that'd be one way of displaying it. Could be a graph. Could we make a table? Okay. If I had a table, I could have X and Y, where X is the age and Y might be our height. So that'd be another way that we could display it. Okay. And what we're going to be looking at is we're going to be looking at tables, graphs, and equations as we look at this unit. Okay? So we're going to be looking at all of these. You want to put that away? Thanks. Your notes from the last unit, I want you to keep those, but your workbooks, later they can be put in the recycling. So it says, in order to model a relationship, we need to identify the variables. We have our independent, or our input, the cause variable, and the dependent, our output, the effect variable. So as you've been working in science also, you've probably talked about the independent and dependent variable. The independent, it says, is the variable that is modeled with the variable x, usually when we think about that. So that's our independent, and our dependent is the y. So when we take a look at how we model this in a table. So when we're thinking about a table, we're going to have either 2 columns, C-O-L-U-M-N, columns, or 2 rows. And usually you're going to have something like this. This would be if we are doing rows. Okay, where we have X and Y, and we have maybe at 1, they were 7, and at 2, 14, and at 3, 21, okay, and we could continue that way. Another way you could see that is you might see hours, or that being our X, and, a little straighter here. And this might be our snowfall. And this would be our y variable, our dependent. And I might have 0 hours, well, we didn't have any snow, and then it started snowing, and we're getting a ½ inch an hour. So if this is 1 hour, I'd have 0.5. And if I had 2 hours, I'd have 1 inch. And if I had 3 hours, I had 1.5. And so our tables can look something like this as you are writing that down. Please make sure you have both tables. So this one is going by rows up here, right, going across. This is a column. So columns usually go down, just like in front of your house. Rows go across. If we are looking at a graph, we are usually going to be looking at a set of points. And we think of those points, they are usually going to be an x, y coordinate. So a set of points in the coordinate plane. So last year you graphed points, okay? When we are looking at this,
Those are plane?
yep, coordinate plane. Last year when you graph points, a lot of ours are going to be in what's called, this is our first quadrant, so please put this graph where you have y and x. And this region here is where a lot of ours will start. And when we talk about that, that is called quadrant 1. So quadrant 1 is where a lot of our graphs are going to be. But there's going to be others in this unit that will be placing them all over. So if I'm looking at this point might be located at 0, -1. I might have another point right here, and I look at that ordered pair, and that's at 1, 0. And I might have another one here, and this would be at 2, 1. Okay? And so when I am graphing in the coordinate plane, I will a lot of times connect these with a line. And my line has arrows on it. So please make sure that you don't just draw segments, but that you draw lines. Okay? When we are doing this, so this is considered our quadrant 1. This is quadrant 2, they go counterclockwise. This is quadrant 3, and this is the quadrant 4, if you are looking at those, okay? So some of our homework later in this unit, they say, well, which quadrant are your points in, or which quadrants, okay, so they're looking at that. When we look at our equations, the equations are really just kind of like our literal equations. A lot of times, it's kind of like our formulas. Our literal equations that we just finished studying. So when we study those literal equations in that last unit, and the reason we had to solve for y, is that usually we are going to have 2 variables in our equation. And ours are usually going to have an x and a y. And the x and y will usually be to the first power. So, an example of an equation that you might see might be something like y equals 2x minus 2. It might be s is equal to 0.5h. They might give you something like the output is equal to, please make sure you're writing these with me, the rate of change times the input. And so these are all different ways that we'll look at tables, graphs, and equations as we do our unit. Okay? As soon as you have this page that's written down, give me a thumbs up so I know we can go to that next page. Okay? So, identifying our variables. It says in 2016, scientists predict the first snowfall of the year will be at a rate of a ½ inch per hour. They also predict that it will snow for 12 hours. We're going to create a table, graph, and equation that will model this relationship. What would be our independent variable? what do you think is the one that we get to look at periodically that we might be looking at? If we're looking at snow per hour, our independent variable probably is going to be our hours. Okay? And in this case, it's going to be the number of hours. And if you think about that, the independent, that's our x. And almost always, time is going to be on the x-axis. Okay? Same with Mr. Olson in science when you do an experiment. Almost always, you're measuring something and comparing it to the stopwatch or time, right? That's your independent. You control when you start and stop the stopwatch when you're measuring that. So in this case, our dependent variable is going to be the amount of snow. How are we measuring the amount of snow? In inches. How do we know that? Because they tell us it's falling at a ½ inch per hour, so it would kind of make sense that that would be. So if we are looking at this, what's our explanation for picking our x and our y, independent and dependent? We might put that the amount of snow, in this case, depends on the number of hours it has been snowing. Okay. So that next one down says, okay, so what is our rate? So some of you are already finishing filling this in and you're looking down at that next one. And it says, to model a relationship with the table, we need to know the rate that the snow is falling. What do we know our rate is? Raise your hand. What do we know our rate is from this problem? How fast is the snow falling? Chris?
½ inch per hour.
So our rate is 1/2 an inch. Someone said, can I use 0.5? Sure, that's the same. Per hour. And the key thing is, anytime you're thinking about rates, you have to usually have this word per, right? It's telling you something's happening every so often. If it's per hour, per minute, per second, it has to give you a per so you know the time. So it says, how much snowfall is there on the first snow when we started the first snowfall of the year? So this is our time, put above the x, put time, and we are talking about hours, right? And this is our snow, y, and this is in inches. So before it started, how much snow did we have before it started snowing? 0. After 1 hour, we should have 0.5, or if you want to put a half. Fill your table in, please. After 2 inches, we should have 1. If you want to put it as 1.0, that'd be the same, right? Then we have 1.5, 2.0, 2.5. It says, use the starting point and fill it in. Once you know that rate of change, you can pretty easily fill it in. So it says you can pick numbers from 0 to 5. How high could we go? What did it say it was supposed to snow for? How long? 12 hours. So we're not going to continue this table through 12, right? But at 12 hours, if it stops snowing, how much snow would we have on the ground? ½ an inch per hour. 12 hours. How much would we have? 6 inches, right? Because what were we doing? We're taking 1 times a half, 2 times a half, 3 times a half gives us 1.5, 4 times a half gives us 2, right? So using that rate of change, you can look at that rate of change as each time we are adding 0.5, right? Each time we added that constant rate of change. Or you could take this number x and multiply it by. So both of those work for finding our tables. So we now want to model the graph at the top of the next page. So first thing, each row of our numbers is an ordered pair. So if you kind of have your notes open to that other page at the same time, the first ordered pair we want to look at was 0, 0. Please make sure you put the parentheses with it, okay? The next one was at 1 hour, we had 0.5. At 2 hours, we had 1.
At 3 hours, we had 1.5. And at 4 hours, we had 2 inches of snow. So each row is that same ordered pair. As we are looking at this, we need labels. So at the top, we probably want to put a title. So we might put snowfall or first snowfall, right? What was our independent variable? Hours. Got to label it. So this would have been 0 hours here. Then we have 1, 2, 3, 4, 5, right? And we really need to go up to our 12 hours. Okay, so please make sure you have your numbers up to 12. And as we are looking at this one, I do not want you to go up by ones. I want this one, I want you to go up by half. So this is going to be a half. This would be 1. This would be 1.5. This would be 2. What are we talking about for our label? Inches of snow. Okay. And now we want to plot those points. So if we are plotting our points, at 0 was 0. At 1, we're going to be at a half. So at 1, we want to go to 1/2. That's going to be this point. At 2, we're going to go to 1. At 3, we're going to go to 1.5. 4 is at 2. If we keep going, 5 is going to be at 2.5. And it says, draw a straight line to connect our points. What did we say that at 12, what's the highest, the most amount of snowfall we're getting? Is 6 inches, right? So make sure you end here. This is not going to be a graph that continues on and on forever, right? Because it starts at 0, so plot your points. It starts at 0 and it ends at 12 hours. That's the weatherman's prediction. I don't think that happened around here. Although I do think in southern Minnesota and South Dakota and North Dakota close to the border, they did have this where they got a lot. Please connect all those points that you had with a line. Now, I will have rulers and straight edges for you to use as we do this unit. So as we are doing this, it says draw a straight line through your points that you plotted. Because I want you to think about, at 1.5 hours, do we know how much snow we're getting at 1.5 hours? Right, we can predict that. Could I predict at 1.85 of an hour? I might not be able to get it exactly, but I'm going to be able to know that it was less than, in this case, that 1 inch, right? I would have another point here. So we really show just usually our points that are the nice, called kind of lattice points or something like that. They're so often referred to. But there are infinitely many points all along here. You just can't see all of them. So you could find what is 6.03 hours, how much snowfall, you could predict that exactly, okay? So we draw this line, it says where does the line start? So we want to put our start was at 0, 0. The stop was at 6, 12. It says, does it need an arrow to show it keeps going? No arrow in this case, right? The reason it's no arrow is they say that it's supposed to stop snowing after 6 hours. After 12 hours, thank you. With 6 inches of snow. Okay? So it says we've already labeled our axes, but as you do your homework tonight, this is the easiest place where students miss points. Like, they don't label what these are. The labels of hours, inches, and then a title. So just make sure as you are doing yours that you always kind of look at those things, because if I don't know, the other thing is putting the X and the Y with those also, okay? So the labels and your X and Y. All right, then we want to model an equation. Now when we model this equation, it says to write an equation for this situation, you need to think about the words first. So using this word bank that I have to the side, we want to think, okay, what are we actually doing as we are looking at that? So if we think about this, we want to be thinking, okay, we are going to find the total amount of snow. So please put, right, amount of snow. And you're going to put equals. What do we know the amount of snow equals? So we are looking at the number of hours, the starting amount, the snowfall rate, and then they give us our operations, okay? So what else do we know? The amount of snow equals what? Our starting, right? And then what did we do? We added what? Plus. So the amount of snow equals our starting amount of snow plus what? Yeah.
Number of hours times snowfall rate.
Number of hours times snowfall rate. And we're going to put snowfall rate first times the hours. Because we don't know the hours, that's what we get to choose. Put this over here just a little bit. Okay? So it says after you've set it up in words, then we want to translate it into a formula with words, replacing the words for variables and numbers and symbols. So at this point, if we are looking at this, we're going to have our amount of snow. We might use S, right? Sometimes I'll have people use A instead of S because they're talking about the amount, right? I would take either one. Okay? If we are looking at those two, it's equal to the starting amount, right? Where did we start? Carmen, what did we start with? 0. So our starting amount, so 0, plus what was our rate as I was looking at that Sage? How fast was the snow coming down, my snowfall rate? 1/2, so 0.5 per hour. So plus 0.5 H. And again, if you wanted to use a fraction, we could use a fraction. So I'll do 1 with a fraction. I'll have you do the same, 1 with a decimal. So write it both ways. Okay? Our starting amount, that was the 0. So it says when we look at this equation, look at the equation and think about the variables and the numbers that they represent as we are looking at this. This was our point. It was a special one right here. This number right here. That was our start point. It was 0, 0. That's where our graph started. Start point on graph. Please put that down. Start point on graph. Okay. The other way that we will sometimes write this equation is what's called, and you'll be asked to write it in, the slope-intercept form. So the snow on our graph was really the y variable, and the hours was x. And so a lot of times we will write our equations in the form with y and x. So snowfall was y equals 1/2 x plus 0. Now you can imagine that a lot of people don't like putting plus 0, right? They don't want to write any extra numbers, so they might have this equation. Are these two the same equations? They're exactly the same, right? So when I look at this one has a start point of 0. This one also has a start point of 0, right? They just don't have the 0 here, okay? And what's going to be nice is that the 1/2 or 0.5, this is our rate of change. And I can always take that times my hours in our table. We kind of talked about that in our table. 1 times 1/2, 2 times 1/2, it gives us all of those numbers, okay? So, we want to take a look at this next situation before we get to your workbook. 3 students are saving money. These are my 3 students. Which student is saving the greatest amount per week, and how do we know? So the first thing we might want to take a look at is that we notice with James, this point is at where? In 3 weeks, how much did he save?
45 mil.
So if you're just looking at the graph, and just raise your hand. So at 3 weeks, he actually had how much, if I'm looking at it, Ryan? Okay, so if you look at this point, at 3 weeks, and you'd go up from 3 and you'd go across here, what did you have? Yeah, don't just always listen to someone who's not too sure sometimes. So we're looking at 3 and 60, right? Can we find, yes, your blurting isn't good all the time. So at this point, could we find out how much per week if it is $60 in 3 weeks? What would you do? Or what are you thinking we could easily do? We know it's $60 in 3 weeks, and I want to find out how much each week. James is doing what? Divide by, we're going to take 60, right? So for this one, we could take 60 and divide it by 3 and say that he is saving $20 per week. Does that look right? If we go to 1 week, it looks like it's about 20. At 2 weeks, it was at 40, right? 3 is 60, so that looks right. As we look at the next person, how can we figure out how much per week? What is Bill saving per week as you look at that? What does it look like from the table? What do you think? $15 per week, right? There's a couple different ways you can look at that. Oh, each week we added 15, right? It went up 15 each time, or 2 times 15 is 30, 3 times 15 is 45, 1 times 15, so 15 per week. And Shawnee is actually saving, we would say probably, A equals 18W, looks like $18 per week. So we now, looking at these 3, and so this is what you'll be asked to do in your homework. Which student is saving the greatest each week? We should have James. His was $20 per week. How do we know? 20 is greater than both 18 and greater than 15, right? Those are what the other 2 people were saving. It says, which is saving the least amount each week? That would be, who's saving the least on our tables? She saved 18. That's less than 15. Bill, right? Bill was looking at saving, if we were looking at this, 15 per week. So, before you put your notes away, I just want you to add a couple other things. It says if you think about, because there's this white space below, you think about what part of each model lets you see the rate of change. So, I need you to write down in a graph, how do we find the rate of change? What we are going to be looking at is taking the change in Y, which in our case was, we're up to 60 from 0, dividing it by the change in our X. And our X at this case was 3, that's how we got 20. And we had $20 per week. Okay? So, just like Mr. Olson on his test, labels are really important, okay? As you do this unit, labels are super important. So putting the money with the weeks and labeling those, okay? How do we know in a table? So with our table, rate of change. When you look at that table rate of change, it is the constant addition in our case, we were adding 15 each week. So that's how they came up with, for our table, $15 per week. Again, labels with the dollars, label with the word. Just putting a 15, I need you to write this. How you're finding this constant addition, that part that you're putting down there, okay? And then in an equation, okay? So you got all that white space, you can go down onto that white space below. In an equation, how are we finding the rate of change? Anytime I look at the equation, we've used the word coefficient before. It is the coefficient of the variable. And we talk about the coefficient of the variable, we're actually referring to the coefficient of the variable x. So when we look at it's the coefficient of our variable x. So when we look at y equals, in this case, 18x, and I think they had a equals 15w, or 18w, this coefficient is telling us $18 per week. Okay? So when you look at that, it's the coefficient of your variable. Okay? So, if you would turn right now to your workbook.
Bless you, Maria.
Bless you. Good. So, there is a front and a back page, so turn in your workbook. 2, you're plotting the point -4. Okay. So -2, -4, plot. Some of you are using your pen at all and putting these on. -1, -2. So you're going to go to -2, and you're going to go label your y up here and your x. So you're going to go to -2, -4. You're going to go to the point -1, -2, 0, 0, 1, 2, 2, 4. Someone said, well, how do I know on this one? At -1, it's down here, which would be -1 and -3. At 0, how do I know that point? Because that's right here. At 1, where is the point? So that's how you're filling those in, okay? In the last one on this page, it says the x values are increasing by 1, the y values are decreasing by 2. And they give you this 1 point. So, if the y values are decreasing by 2, at 1, where should this be? If they're decreasing. If it was at 0, it should now be at, decreasing by 2 would be -2. So at 1, down at -2. And you should be able to fill in the rest of these, and then you need to answer over to this side on this side of the question. On the back of this, question 2, please turn and look at this right now. In question number 2, it says, okay, we're looking at these 2 companies renting out like our videos for us, and it says, and what you want to do, it says make a table for each. So you want to start this with Eric's Shack and how much they're charging, and then we have Mr. Otterson's, and they are charging us for video, how many videos you get, and then you have to rent it, how much they rent for. So my hint is both of these tables are going to look the same. And you're going to both start out at 0 videos, and you want to go up to 4. So 0, 1, 2, 3, and 4. Same thing here, 0, 1, 2, 3, and 4. When you do these, after you've filled in using the information up here, you are then going to graph it. Make sure I have labels. It says use a solid line for Eric's Video Shack, so that one's going to be a solid, and use a dashed line for Mr. Otterson's Entertainment. And then you should be able to look at question 3 and answer that one. So you have 3, A and B. Those are writing the equations. So you've had a table, and you've had the graph, and you're practicing equations, and you have the front and back of this for tomorrow that is due. Okay?